for trouble-free operation of these technically perfected engines. This video film comprehensively describes the jobs using hydraulic tensioning tools. These are required to tighten and untighten the big bolted connections. We will inform you on all points of interest in 6 sections. You will learn why, when and where the jobs are to be done. We show you the tools required and explain their functions. Then we will first demonstrate the correct tightening operation. Important notes on safety are given in the 4th section, and untightening operations are subsequently shown in detail. Finally, instructions on tool care are given. This video film is thought as a supplementation of written pieces of information of the technical documentation, that is, the operation instructions and the working instructions. It is no substitute for this written information. We shall use this symbol as a reference to the relevant working cards. Please read them carefully prior to starting on the job. Safety first. Always remember this principle when doing maintenance work. This symbol is used to mark significant notes on how injury to persons or damage to components can be avoided. We are convinced that this video film will be of valuable assistance to you in doing your responsible job. We wish you every success.
We have developed the MAN B&W 4-stroke engines to very compact and powerful engines during the past years. In this process, bolted connections become increasingly important, highly loaded constructional elements. This is now demonstrated on 2 representative examples of our modern engine family. The longitudinal section of the L58-64 engine is shown, and the cross-section of the L40-54 engine. Vital bolted connections are those of the main bearing, vertical and horizontal. The cylinder head, the big end bearing, the camshaft bearing, the balance weight of the crankshaft, the engine to the foundation, as well as those of the torsional vibration damper and the coupling flange. These bolted connections are exposed to the high loads becoming effective in engine operation. Therefore, they have to be checked at exactly fixed intervals, and of course they have to be slackened and retightened during maintenance work. Vital bolts of smaller diameters are tightened using torque wrenches. To tighten bolts of larger size, hydraulic tensioning tools are required. Hydraulic tensioning tools call for high pressures. Great care is necessary in their use, otherwise persons may suffer injury or machinery components may get damaged. This video film illustrates the correct execution of jobs. The technical documentation contains additional detailed descriptions of the tools required, of operational steps, and the technical details you have to observe. Please read these instructions before you start on the job. The tools required for working with hydraulic tensioning equipment are supplied by MAN B&W together with the engine. These include the tensioning equipment proper. Depending on the purpose they are intended for, we use simplex tensioning tools, duplex tensioning tools, or tandem tensioning tools. In the following, jobs will be illustrated using the simplex type of tensioning tool. To use a tensioning tool, you'll need a thrust piece to transmit the pressure forces to the components. Some bolts require an adapter between the threaded socket and the tensioning tool. Also required is a high-pressure pump operated on compressed air to generate the necessary oil pressure. high-pressure hoses which safely transmit even high oil pressures from the pump to the tensioning tools. And an opener that is required where non-return valves on the hose or on the tensioning tool have to be opened. Tensioning tools without an own reset mechanism need a separate resetting device. A dial gauge with magnetic post is provided for working on specially significant bolts. It allows to control the elongation of the bolt independently of the oil pressure recording. Parts belonging to the standard tools, such as a Tommy bar to slacken and tighten the nuts, are also necessary. As already mentioned, the hydraulic tensioning tool requires high oil pressures to operate. The oil pressures are produced by the pump and transported in jacketed hoses. Now we'll demonstrate the tensioning mechanism schematically. The bolted connections to be tensioned all have an elongated threaded socket. The nut is screwed in place hand tight. The tensioning tool itself consists of the piston, which is applied to the threaded socket, the hydraulic oil connection, and the casing. The casing bears against the thrust piece. Thin-bodied oil is pumped into the casing of the tensioning tool under high pressure. It forces the piston upwards. As the piston is screwed onto the threaded socket, the bolt is elongated. The piston lift depends on the oil pressure and the kind of bolted connection. It amounts to several millimeters on the main bearing bolts, but is restricted to several tenths of a millimeter as a rule. This elongation is adequate to further tighten the nut to the correct tension using the Tommy bar. When the oil pressure is reduced to zero, the bolted connection is finally tightened and the tensioning tool can be removed. So let's start. No, stop for a moment. You should never start on the job without having the work card with the oil pressures and tensioning values at hand. This table lists the related work cards too. The individual work cards are sealed in a protective foil to allow them to be taken from the technical documentation to the engine. So now we start the job. Please remember, you encounter high pressures when working with hydraulic tensioning tools. Therefore, it's of great importance that all the individual steps are carried out carefully. Make sure you wear safety goggles. Make sure that high-pressure hoses and tensioning tools are not defective. Regularly check the oil level and the pressure gauge of the high-pressure pump. Keep your tools and the equipment required for the job available at the engine and consult the work cards once again. Threads and contact faces must be clean, free of damage and lubricated. Tighten the nut by hand using the Tommy bar. This kind of engine requires an adapter to be screwed onto the cross tie rod. Then put the thrust piece in place. Make sure that the piston has been fully forced into the casing prior to screwing it in place. Should the piston not have been reset, it may get canted and could cause a sudden ejection of oil. Then screw the tensioning tool onto the threaded socket or the adapter. In the case of this bolted connection, a tensioning tool should be applied on both sides of the engine. Now you can connect the high-pressure hose. It must be completely filled with oil and the unloading valve of the pump must be open. It's advisable first to connect the hose to the high-pressure pump. Pull back the union ring and introduce the coupling. The union ring then slides back over the coupling. The retaining ring is screwed subsequently in place. In this way, an inadvertent opening is prevented. The outlets on the pump which are not used have to be plugged by dummies. Is everything ready to operate? Check back in the table again what pressure is necessary and then switch on the pump. For this purpose, the switch on lever has to be in position 2, off. Then connect the pneumatic air pipe. And adjust the pressure regulating valve so that the pressure gauge reading ranges at approximately 1 bar. Then move the switch on lever to position on and subsequently close the unloading valve. Then turn the pressure regulating valve stepwise until the pressure gauge indicates the desired pressure. The oil now forces the piston upwards. The bolt is tensioned in this way. If the pump is required to produce a pressure higher than 1100 bar, this range must be expressly cleared. The tensioning tool has now elongated the bolt and lifted the nut. The nut can now be tightened by hand using the Tommy bar. After releasing the pressure, the bolted connection is in the correctly tensioned state. The pump is now switched off and the unloading valve is opened. The oil pressure on the pump immediately drops to 0. The pressure in the hose, however, drops more slowly. Whenever the tensioning tool has been used, make sure that the piston of the tensioning tool returns to its home position. On tandem tensioning tools and special simplex type tensioning tools, this is done automatically by spring force. It's essential that in this case you wait for at least 2 minutes after having released the pressure before you dismount these tensioning tools. Premature disconnection of the hose may cause the non-return valves to become blocked so that the hose cannot be connected again. The oil flows back more easily from the tensioning tool to the pump if the hose is connected to the return flow fitting of the high pressure pump for a while. On the standard type of simplex tensioning tools and on duplex tools, this resetting is to be done by tightening the tensioning nut or by hand with a resetting device. The best is to reset the tool as long as it is still mounted on the bolt and connected to the pump. The resetting device is placed on the piston. The legs enter the pocket holes on the casing. Then turn the thrust spindle until the piston is seated firmly against the base again. If the tensioning tool is no longer connected to the pump, the non-return valve must be forced open to permit the oil to escape before the tool is reset. For removal, the high-pressure hose should preferably first be disconnected from the high-pressure pump and the outlet should be plugged with a dummy again. The hose must then be disconnected from the tensioning tool. Now you can screw off the tensioning tool and take off the thrust piece. The tensioning process is now complete. Before starting on the job proper, study the safety instructions that follow. Then we'll show you the necessary working steps and details for releasing the bolted connections. Never forget the safety goggles, indispensable for protecting your eyes against hydraulic oil that may eject under high pressure. And to be on the safe side, wear gloves. In case of tensioning tools with an auto reset device, do not remove the high pressure hose immediately, but wait for at least 2 minutes to let the pressure reduce. If you disconnect the hose too early, a jet of oil may eject and you run the risk of getting hurt. Before screwing off the tensioning tool, make sure that the piston has been completely forced into the casing. Otherwise, a jet of oil may eject on the next occasion, or the piston could become canted. The big bolted connections on four-stroke engines, such as the tie rods and cross-tie rods, have to be released and retensioned at certain intervals as a precautionary control measure. These control intervals and the related work cards can be looked up in the maintenance schedule. Of course, you must also undo bolted connections to work on this component or the neighbouring ones. Releasing differs distinctly in some points from tensioning, so please carefully watch what we're showing you now. To start with, the procedure is graphically illustrated on this computer animation. The reset tensioning tool has been screwed in place, hand-tight as usual. The piston and casing of the tensioning tool are now turned back by the appropriate number of angular degrees. This angular amount of turning back is what is required to finally release the nut. It can be checked in the table of tensioning values in the technical documentation. When the high pressure pump has been started, the first phase is that the gap between the casing and the thrust piece is closed. As the oil pressure increases, the bolt is gradually elongated far enough to release the nut. And the nut can be turned back by hand. Provided the nut is turned back precisely by the angular amount, the bolt will loosen as the oil is depressurized. As soon as the tensioning tool has been detached, the nut can be removed. Let's sum up the preparations for the job. Of course, you have to put the thrust piece in place. Make sure the tensioning tool has been reset before you screw it in place. And remember, turn the tensioning tool back by the appropriate angular amount prior to connecting it to the pump. If you neglect the correct angular amount, it might not come loose when the nut is unscrewed. Connect the tensioning tool with the high pressure hoses to the pump. This has already been demonstrated before. Look up the correct pressure in the table of tensioning values and start the pump as already shown. The oil pressure now pushes the casing downward. The gap relative to the thrust piece is closed. The oil pressure is now slowly to be increased to the prescribed tensioning pressure. Try in between at short intervals to see whether the nut already comes loose. As soon as this is possible, the releasing pressure must be noted down. This must be known when judging the tension of the screw. The nut will possibly stick longer than expected. In such a case, it's permitted to increase the pressure by a maximum of 5% above the value stated in the table. If the nut still cannot be loosened, proceed as specified in the work card. The same applies analogously in case the connection was not tight enough. If the nut is loose, turn it back exactly by the corresponding angular amount. In doing so, strictly adhere to the data given in the tensioning value table. As desired, the bolt becomes loose as soon as the oil pressure is reduced. Note, in case of auto-reset tensioning tools, make sure to wait long enough for the pressure to reduce before you remove the high-pressure hoses. There we are. The bolted connection is now loose.
Well, I think this video film appropriately illustrates the maintenance jobs to be done. And please remember, the work cards included in the technical documentation contain more technical details. You should take recourse to this source of information whenever you have to do maintenance work. Should you encounter difficulties, please don't hesitate to contact our diesel team in Augsburg or Hamburg or one of our service bases all over the world. We wish you every success with your work and trouble-free operation of our MAN B&W diesel engines at all times. Let me say goodbye to you now. A few tips on the maintenance of tools are following.
Make sure you check the oil level in the pump prior to use. Change the oil and clean the oil space once a year. Treat the high-pressure hoses with care in order not to damage them, because a jet of oil might be ejected under pressure. The hoses must not be bent or rolled up excessively. For storage, the hose couplings should be slid into each other or closed off. If pressure testing leads to an unsatisfactory result and if leaks are found, the sealing rings have to be replaced. Make sure to use original spare parts for this purpose. For more detailed information, please refer to the work cards. We strongly advise against any inadmissible manipulation on the hydraulic tensioning tools. In case of problems, please contact the MAN B&W diesel team or the nearest MAN B&W service base.